Okay, is it audible what I am saying? Students, one of you can just type yes in the chat box over there. Okay, yes. Okay, so we will begin with this part. So here, in case of differentiation now, okay. So already we have covered matrices and determinant part. Okay, matrices and determinant part is over in the last 4 classes. Okay, so now today we will be discussing the questions on continuity. Okay, so continuity again, the question, the question will be occurring for 4 mark. Okay, this question will occur for 4 mark. Matidu part E nalle every year occur ಆಗ್ತದೆ question part E. So in this question, to solve this question, first we require 2 essential points. We will discuss those 2 essential points. Okay, try to understand. The first definition we require continuity at a point. Okay, so continuity of a function of f of x, okay, at a point that is at x is equal to a. Okay, so at a point a. So here we have a simple definition you might have already studied in your college. So this is just a revision class for you, and we will be focusing on the main question. So the definition is a limit of f of x as x tends to a is equal to f of a. Okay, so this is the first definition we are using to discuss the continuity at the point x is equal to a. Okay, first definition. Okay, and then the second definition here, the second definition to discuss the continuity of f of x is LHL is equal to RHL is equal to f of a. Okay, so this is the second definition here. So this is in symbolic form, you can write it as limit f of x as x tends to a minus. Okay, so for LHL you need to use negative sign. For RHL you need to make use of a positive sign. So it will be x tends to a plus. Okay, and this must be equal to what? F of a. Okay, so here 2 definitions are given. Okay, 2 definitions are given. The first definition is to discuss the continuity of a point at a point. Okay, so when the function is defined at a point, okay, we are making use of the first definition. It is limit of f of x as x tends to a is equal to f of a. Mattu the second definition, okay, we are making use of the second definition when it is defined on a interval. Okay, so when it is defined on an interval, in the sense here, see, try to understand this. We will discuss an example. See, on an interval. So when the question consists of inequalities. Okay, so if the function is defined in terms of inequalities, that is less than equal to greater than or greater than equal to and less than. So when inequalities are used, okay, when inequalities are used, okay, so the point will be given, but the values less than a will also be given, the value of the function, and the function will also be defined at the values greater than a. Okay, so when such a question is been asked, that is the value of the function at a point is given, less than that, the value of the function at the point less than a is given, and then the value of the function at the point greater than a is given. So when such kind of inequalities are occurring in the question, okay, we are making use of the second definition. So a second definition, it states that LHL is equal to RHL is equal to f of a. Okay, so we need to make use of these 2 conditions, and using these 2 conditions we can discuss the 4-mark question over here. Okay, we can make use of the, we can discuss the 4-mark question. Okay, so a 4-mark question occurs every year in this. Okay, so yes, so we will continue. So 4-mark question, it is a part E question occurs. So we will start with the first question over here. So just you all take a screenshot of this. Take a screenshot of this and definition, the first definition and the second definition. Okay, so in this question they will be already given. Okay, the function is continuous. So function is continuous. So already in the question they mentioned that the function f of x is continuous. Okay, the function f of x is continuous, and when the function is continuous, it satisfies the definition. Okay, so as per the question, we are making use of the one of the two definitions. Okay, either the first definition or the second definition. Okay, so question nalle already ಕೊಟ್ಟಿರುತ್ತದೆ. Okay, they already give what they give, the function is continuous. Okay, so when they tell the function is continuous, okay, it is satisfying both the definitions. It is satisfying both the definitions. Okay, so take a screenshot of this definition, and then we will discuss the first question. Yes. So we'll be discussing the first one. Okay. So pay attention. The first question here, see the find values of k so that the function is continuous at the indicated point. Okay, the function is continuous at the indicated point. So here the function is given f of x is equal to kx square and 3 if x is less than equal to 2 and if x is greater than 2 at x is equal to 2. Okay, so we need to discuss the continuity of the function at x is equal to 2. So, but when they are defining at that point, when they are saying the function is continuous at that point, and they have also defined the function at less than 2 also, as well as greater than 2. Okay, so to solve such type of question, okay, so here we are making use of the definition 2 of the continuity. Okay, so just we discuss the definition 2. So see, to solve this, you can just draw a rough figure over here. Okay, you can draw a rough figure over here with pencil. Okay, hope you all have taken a pencil and book with you. So say try to understand this. So here what I am doing is I am considering the point as what 2. Okay, the point as 2. So see the value is less than 2, I will indicate it as 2 minus, and the value is greater than 2, I am indicating it as 2 plus. Okay, so again we will observe the question over here. See f of x is equal to kx square. So it is equal to kx square. See at two values here. So less than is given as well as equal to is given. So when it is less than, the value of the function is kx square, and when it is equal to 2 also, the value of the function is kx square. Okay, so say at equal to 2. So here I am writing the function is kx square, and less than 2 also, the value of the function is what? Kx square. Okay, now here we have the third definition for the function. See f of x is equal to, so it is defined in three ways. In the third case, what it is, they are saying f of x is equal to 3 when x is greater than 2. So x is greater than 2 means 2 plus. Okay, so in this case the value will be equal to what? 3. The value is equal to 3. Okay, so if you draw this rough figure, there will be no confusion. Okay, and using this figure, now we will solve this question. Okay, so solution. So we need to discuss the continuity of the function, okay, at x is equal to 2, and it's already given in the question, f of x. So the first step what we are writing is f of x is continuous. Okay, is continuous at what? At x is equal to 2. Okay, and since it is continuous at x is equal to 2, so say at x is equal to at x is equal to 2, what is the function? F of x is equal to, see, when it is equal to 2, the value of the function is what? K x square. Okay, okay, it is k x square. The value of the function is k x square. Are you able to hear me, students? Is the audio clear? Are you able to hear me? No problem. The audio. There's no problem with the video and audio, just I guess. Vedavati or Priyanka, anyone of you can type yes. If there is no problem. Is it clear? Yes? Is it clear? Just one of you can type yes. Okay, one of you type yes. Okay, so see, we will continue with the next part. Okay, here see at x is equal to f of x is equal to k square. So on simplifying this, we get f of 2. There is x replaced by 2, so it will be 2 square. Okay, or 2 square it will be equal to 4, so it will be equal to 4k. Okay, so f of 2 value is 4k. Next, we need to calculate the LHL, left hand limit. So left hand limit is nothing but what limit of f of x as x tends to 2 minus, at x tends to 2 minus. So when it is less than 2, in place of replace the function, the value of the function is kx as x tends to 2 minus. Simplifying, see, when we take limit, we x with the it is tending. So here x is tending to 2. So replace x with 2. So we get 2 square. Okay. So once you take out the limit, so you are free to substitute the value of x only when you take out the limit. If you don't take out the limit, and if you substitute, you lose mark. Okay. So once you take out the limit, you need to replace x with the value of x. Okay. Next, x 2 square, so it will be equal to what? 4k. So LHL we have calculated. Similarly, we need to calculate now RHL. Okay, is the screen visible? Are you able to hear me, students? Just one of you type yes. Vedavati, Priyanka, anybody? One of you type yes, so we will continue. Yes, okay, okay. Yes. We'll continue with the example. Yes, pay attention. Is the screen visible now? Okay. Yes. See, pay attention. Okay, so we had just discussed this. Just I will repeat it once again. So here we had considered 2 minus, okay, and then 2 plus, okay, 2 minus and 2 plus, okay, 2 minus 2 plus. So see, when the value of the function is less than 2, sorry, we need to discuss that question. 1 minute. First here.
Hotspot on the ಎಷ್ಟು ಮಂಚ ಇರುತ್ತೆ
Is the screen visible now, students? Just check it once. Okay. Yes. See, pay attention. I will continue with this. Once again, see, just pay attention. Yes. Okay. So we need to discuss the continuity at 2. Okay. At 2. So 2 minus, again we have 2 plus. So see, when it is less than 2, it is kx square. At 2 also it is kx, the value of the function, and greater than 2 it is 3. Okay. So in the solution part, we are discussing. Okay. So in the solution part, we are discussing first by considering. So we are discussing the solution by considering what the function is. So in the question it's already given the function is continuous. So write down f of x is what continuous. It is continuous. Okay, at x is equal to 2, and it is continuous at x is equal to 2. So by the definition, so at x is equal to 2, okay, we apply the definition. So f of x, see, when it is equal to 2, the function value is kx square. Replace x with 2, so we will be getting it as 4k. We will be getting it as 4k. Then already we discussed how to calculate LHL. LHL is equal to limit of f of x as x tends to 2 minus. So when it is less than 2, the value of the function, see, the value of the function is again kx square. So limit kx square as x tends to 2 minus. So now once you replace, when you take out the limit, okay, you replace x with 2. So we need to substitute x with 2. So again it will be equal to 4k. Similarly, we will be calculating the RHL now. So RHL, limit of f of x as x tends to what? X tends to 2 plus. So this will be equal to limit. So when it is greater than 2, the value of the function is 3. Okay, so just substitute the value. Okay, and when no x is involved, directly the constant will be the value. So that will be equal to 3. So now we are making use of the definition and finding out the value of what k. Okay. So see, already the function is continuous. Okay. So f of x is continuous. F of x is what is continuous, and since it is continuous function, okay, it will satisfy the definition. Okay, LHL is equal to RHL is equal to what? Is equal to value of the function, that is f of 2. It is equal to what here? F of 2. Okay, so see, take any two values here. See here, f of 2 value is 4k, LHL is also equal to 4k, and RHL is equal to 3. So take any two unequal value, that is a non-repetitive values. See, 4k is repeated here, so take only 4k once. Okay, so 4k will be equal to what? 3, and k will be equal to what? 3 by 4. Okay, so value of k will be equal to 3 by 4. So this is how we need to discuss, we need to solve this question over here. Okay, so simple, the only very few simple steps are there. So first we need to find out the value of the function at the given point. Next we need to calculate LHL, and then calculate RHL, and then by making use of the definition and equating the uh, unsimilar terms. See, 4k and 3 are not similar, okay, but according to the definition they are equal. We can find out the value of the unknown term. Okay, so this is how we can calculate k. Okay, so a very simple question. Take a screenshot of this. We will be discussing the next one. Yes, okay, hope you have understood this question. All have understood the question. Okay. So we'll be discussing the next question now. It's question 2. Similar question related to this previous question only. Yes. So we will discuss the second question on this. Yes. Okay, next question. Question number 2. Okay. So here only the point is changed. See, the question is exactly same. Okay, find the value of k so that the function f is continuous at the indicated point. Okay, so here the indicated point is 5. Okay, indicated point is 5. So again same, the same steps we are following. We'll discuss this one solution. Okay, so we need to check the already it is said the function is continuous at 5. Okay, so you can draw this sketch of, okay, 5, then we have 5 minus, okay, and then 5 plus. Okay, so see, when it is equal to 5, see the equal to sign is over here in the first part here, so equal to 5. So when it is equal to 5, the value of the function is kx plus 1. Okay, it is kx plus 1. Next, when it is less than 5, the value of the function is same again, kx plus 1. See, when it is less than, the value is when it is less than, it is kx plus 1. When it is equal, also it is equal to kx plus 1. And now when it is greater than 5, when it is greater than 5, the value of the function is what? The value of the function is 3x minus 5. Okay, it is 3x minus 5. So again we will follow the same steps. Okay, so the first step what we need to do is, first step ಏನು ಮಾಡಬೇಕು ಇಲ್ಲಿ, we need to write down the definition. Okay, we need to write down f of x is what? Continuous. Okay, f of x is continuous at what? At x is equal to 5. So f of x is continuous at x is equal to 5. So f of x, see, at x is equal to 5, what is the value of the function? Kx plus 1. Replace x with 5. So f of 5 will be equal to 5k plus 1. Okay, so this is the first value, that is f of 5. Next we need to discuss LHL. So LHL is a limit of f of x as x tends to what? 5 minus. Okay, so when it is less than 5, again the value of the function is same, that is kx plus 1. Okay, as x tends to 5 minus. Now replace, take out the limit. So when we take out the limit, we are replacing x with 5. So again it will be equal to 5k plus 1. Okay, so out of the three values, two values we have got. Next, we need to calculate the RHL now. Okay, RHL. So RHL limit of f of x as x tends toward 5 plus. Okay, 5 plus, so greater than 5. So replace a limit. So when x is greater than 5, the value of the function is 3x minus 5. Okay, it is 3x minus 5 as x tends to 5 plus. Okay, replace x with 5 now after taking out the limit. So 3 into 5 minus 5. So 15 minus 5, it will be equal to 10. Okay, so again we will be making use of the definition of continuity. Okay, by definition, okay, LHL will be equal to what? RHL will be equal to f of 5. It will be equal to f of 5. So say what is the value of LHL? Try to take two unsimilar values. So see 5k, three values we have out of 3. So see here we have 5k plus 1, and that is f of 5 value 1, 2, and then again 3. Okay, so but out of 1, 2 and 3, try to take the two unsimilar values. See 5k plus 1 and 10. So you will get the value of the constant. So 5k plus 1 is equal to 10, and 5k will be equal to 10 minus 1, which is 9, or k will be equal to 9 by 5. Okay, so k will be equal to 9 by 5. So the answer will be 9 by 5. Okay, so this is how we can solve this example. So in the exercise on continuity, 6 to 7 examples are there over there, where already they say the function is continuous. We need to find out the value of k, or find out the value of a and b, m and n. So whatever the constant is given in the function, we need to calculate those values. Okay, hope the example is clear. Yes, is it clear? Yes, some of you have answered it. Okay. Next, we will discuss another important question based on this, and the third question of the today's class. Okay, third question. Question number 3. Okay, question number 3. Okay, so this is the third question. Now find the value of k so that the function f is continuous at the indicated point. So here the indicated point is pi. Okay, the indicated point is what? Pi. That is x is equal to pi. So at pi we need to discuss the, means already the continuity is given. It is, they are saying the function is continuous. We need to find out the value of k. Okay, so this example 3 is similar to the first two examples. Okay, so I am giving it for homework. Okay, try to solve it for homework. And see, f of x is equal to kx plus 1 and cos x at x is equal to pi. So less than pi value is given, equal to pi is given, greater than pi is given. And here you remember the value of cos pi. Okay, what is cos pi? Anybody? Cos pi value, cos pi, cos 180. Okay, and also you need to remember sine 180, cos 180 and sine 180. What is the value of cos 180? Okay, cos 180, it is equal to what? Minus 1, and sine pi it is equal to 0. Similarly, what is tan pi equal to? Tan pi. Okay, so these simple values you need to remember. I hope you know the trigonometric table. Okay, so sine pi, tan pi, it is equal to 0. Cos pi is minus 1. And what about cos 3 pi by 2? Cos 3 pi by 2. So these simple values from the trigonometric table you need to remember. Okay, so at even multiple, the value will fluctuate between minus 1 and 1. Sine pi, even multiple, it will be 0. Odd multiple, again the value will fluctuate between minus 1 and plus 1. Okay, so using this you can easily solve the example, and the answer for this, the value of k is minus 2 by pi. So the value of k, the final value you will be getting it as minus 2 by pi. Okay, so solve it for homework, then we will discuss the next question over here. So here, so see, the question is similar, but here we need to find out two values. Okay, so we need to find out the value of A as well as B. Okay, we need to find out the value of A as well as B. Okay, value of A as well as B. Okay, so most of the time this question is been asked, as it is the question is been asked. Okay, so find the values of A and B such that the function defined by f of x is equal to 5, ax plus b and 21. Okay, but see here they are given 2 points where the inequality is occurring. See, at 2 less than 2 equal to 2 as well as at 10. Okay, so 2 points are given, so we need to make use of the definition of continuity two times. Okay, we need to make use of the definition of continuity two times. Okay, and simplify it. So we will discuss this example. Okay, so pay attention. So first we will try to draw the rough figure for this example. So say, try to understand the question first. So here we have, see, 2 points are there. Okay, where the function is defined. The function is defined at 2. Okay, then 2 minus. Okay, and 2 plus. So say when it is equal to 2, you can see the value of the function is equal to 5. When it is greater than 2, it is equal to ax plus b, and less than 2 also the value of the function is equal to 5. Okay, so this is at the point 2. Similarly, the function is also defined at the point 10 also. It is defined at the point 10. So 10, okay, less than 10, and then 10 plus. So see, when it is less than 10, the value of the function is again ax plus b. Okay, see over here, you can see here they have defined it. So when it is less than 10, so when it is less than 10, the value of the function is what? Ax plus b. Okay, and now when it is greater than 10, it is equal to 21, and equal to 10 also it is equal to 21. So at 10 it is 21, and greater than 10 also it is equal to 21. Okay, so this question again we are using the same steps. Okay, but the procedure is little lengthy. Okay, so first we will find the check the continuity of the function at see, pay attention. So first we will be finding it at 2 first. Okay, so already the function is continuous. We will find out the value of the constant at 2 and then at 10. Okay, so pay attention. Okay, so in the solution part, first we will discuss at see, at x is equal to 2. Okay, so at the point x is equal to 2, see the value of the function at x is equal to 2, f of 2, f of x is equal to what? 5, or f of 2 will be equal to 5. Next we will be calculating the LHL. So LHL is equal to what? A limit of f of x as x tends to 2 minus. Okay, so when it is less than 2, again the value of the function is what? 5. So x tends to 2 minus, so the final answer is what? 5, LHL. Similarly, we have to calculate RHL. RHL is again equal to a limit of f of x as x tends to 2 plus, which is equal to a limit. See, value of the function when it is greater than 2, it is ax plus b. Okay, as x tends to 2 plus. Okay, or on simplifying we get it as 2a plus b. Okay, 2a plus b. Okay, now use the definition of the continuity. So by making use of the definition of continuity, see, it's already given the function is continuous. So f of x is what? Continuous. Okay, f of x is continuous at x is equal to 2. Okay, and since it is continuous at x is equal to 2, LHL will be equal to what? RHL will be equal to f of 2. Okay, so using this we can write it as, see, equate the two unsimilar values. So 2a plus b will be equal to 5, and this we are considering it as equation 1. Okay, we are considering it as equation 1. Okay, so we have got the equation 1 at x is equal to 2, that is 2a plus b is equal to 5. Similarly, now we need to check, we need to get a equation by considering the point x is equal to 10. Okay, x is equal to 10 we need to consider, and try to simplify it. Okay, so see, pay attention. I'll solve it here. This rough figure I'm taking out. Okay, so second equation we need to get. So see, for the second equation, what we need to do is, so same again. We need to discuss the continuity at what? At x is equal to 10. Okay, so at x is equal to 10, see, at x is equal to 10, f of x, see, when it is equal to 10, it is equal to 21. So f of 10 is equal to 21. Similarly, calculate the LHL. LHL is equal to limit of f of x as x tends to 10 minus. So when it is less than 10, the value of the function is ax plus b. So this will be limit of ax plus b as x tends to 10 minus. Okay, or this will be equal to 10a plus b. Okay, 10a plus b. Similarly, we need to calculate the RHL. So in the RHL, what we need to do is limit f of x as x tends to 10 plus. Okay, so when it is equal to 10 plus, the value of the function is again 21. So this will be equal to limit of 21 as x tends to 10 plus, or this will be again equal to 21. Okay, so again use the same definition. F of x is continuous at x is equal to 10. Okay, so same again, LHL will be equal to RHL will be equal to 21, or what do we get? See, 10a plus b is equal to 21, and this will be our equation number 2. Okay, so now what we need to do is we need to solve these equations 1 and 2 and find the value of a and b. Okay, so solving 1 and 2. Okay, 1 and 2. Okay, so we are solving it simultaneously. See, 2a plus b is equal to 5. Okay, and 10a plus b is equal to what? 21. Subtract this. Okay, so when we subtract this, it will be minus b minus. Okay, and again minus. So plus b minus b will cancel. On simplifying it further, we get simplifying it further, we get minus 8a. Okay, minus 8a is equal to minus 16. Okay, or minus 16, or on simplifying we get a is equal to 2. Okay, so a is equal to 2, and a is equal to 2. When we substitute in equation 1, we get 2 into 2 plus b. Okay, 2 into 2 plus b is equal to what? 5, or b will be equal to 5 minus 4, that is equal to 1. So value of a is equal to 2 and value of b is equal to 1. Okay, so this is also a 4-mark question which has been occurred in the previous year. Okay, so similar one more question I have given here. I will just go towards the question. Okay, so take a screenshot of this. So here we need to use two given points. Okay, first we need to make use of a 2, and then we need to make use of a 10. Okay, hope the example is clear. ಎಲ್ಲರಿಗೆ ತಿಳಿಯಾಕತೈತಿ? Okay, is it clear? Just you can type yes if you have understood. Okay, and see, only class ನನ್ನ ಜೊತೆ ಮಾಡಿ ಯೂಸ್ ಇಲ್ಲ. ಯು ನೀಡ್ ಟು ಪ್ರಾಕ್ಟೀಸ್ ಇಟ್. ನೀವು ಮತ್ ಸ್ವಂತ ಮನೆಯಲ್ಲೇ ಒಂದೆರಡು ಸಲ ಎಕ್ಸಾಂಪಲ್ಸ್ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಬೇಕು. ಓಕೆ, ಮತ್ತು ಕ್ವಶನ್ ಪೇಪರ್ಸ್ ರೆಫರ್ ಮಾಡಿ ಲಾಸ್ಟ್ 5 year ಪೇಪರ್ಸ್ ಯು ಟೇಕ್ ಔಟ್. ಆ ಕ್ವಶನ್ ನೋಡ್ರಿ, ಈ ಕನ್ಸೆಪ್ಟ್ ಮೇಲೆ ಯಾವ್ಯಾವ ಕ್ವಶನ್ಸ್ ಬಂದಿದ್ದಾವೆ ಆ ಕ್ವಶನ್ಸಿಗೆ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ ಆನ್ಸರ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಕ್ ನೋಡ್ರಿ. ಸೊ ಒನ್ಸ್ ಯಾವಾಗ ನಿಮ್ ಕನ್ಸೆಪ್ಟ್ ಕ್ಲಿಯರ್ ಆಗ್ತೈತಿ, ಅದ್ ಕನ್ಸೆಪ್ಟ್ ಯೂಸ್ ಮಾಡಿ ಮತ್ ಸ್ವಲ್ಪ ಎಕ್ಸಾಂಪಲ್ಸ್ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಕ್ ನೋಡ್ರಿ. Yes, okay. So next we will continue, and a very important example here. So see, similar to this this question I will be discussing, 5th question. The 6th question, what I am see this question now, which is getting displayed on the screen. That is, find the relationship between a and b so that the function. So here only one point is given, but they are asking us to find out the relation between a and b. Okay. So LHL and RHL you will get, equate those and find out a condition which is relating A and B. Okay, you have to find out the condition which is relating A and B. Need not find what is value of A and what is value of B. Only we have to find a condition which is relating A and B. Okay, and then we will discuss the last question of today's class, and a very important question. This question also has occurred two times. Okay, two times the question has occurred already in the previous 5 6 years. Okay, so pay attention. Okay, so in first year you have already studied about limits. Okay, and there you might have come across substitution method. Okay, substitution method. So by making use of substitution method we can solve this example. Okay, see, the question is very simple again. The find the value of k so that the function is continuous at the indicated point. So the function is defined. Say at x not equal to pi by 2, the value of the function is k cos x divided by pi minus 2x, and equal to pi by 2, it is equal to 3. So we need to find out the value of k when the function is continuous at what, x is equal to pi by 2. Okay, so here less than equal to sign is not given. Okay, less than equal to sign is not given. Instead of that, equal to and non equal to is given. Okay, equal to and not equal to is given. So here we can make use of the first definition, what we discussed. Okay, and by making use of the first definition, we can find the value of this function. Okay, so here to solve this example, two important things we require. Okay, one is two basic formulas we need to remember. That is cos of pi by 2, cos of pi by 2 minus theta. Using allied angles, cos of pi by 2 minus theta is equal to what? It is equal to sine theta. In first quadrant, it is equal to what? Sine theta. And similarly, one more formula from limits we are using. A limit of sine theta upon theta as theta tends to 0. Okay, this formula you might have come across last year. So limit sine theta upon theta as theta tends to 0 is equal to 1. And last year one more formula we have discussed in limits, x raised to n minus a raised to n upon what, x minus a as x tends to a is equal to n a raised to n minus 1. Okay, so these two formulas, out of these two formulas we are making use of the formula limit of sine theta upon theta as theta tends to 0 is equal to 1. Okay, so we will discuss this example. So these two formulas we are using, cos pi by 2 minus theta equal to sine theta, and limit of sine theta upon theta as theta tends to 0 is equal to 1. Okay, so we'll continue with the example. Yes. Okay, so in the solution, so we are making use of the first definition. So first definition, what it says, a limit of f of x as x tends to what, a is equal to what, f of a. So here the point is pi by 2. Instead of a, here it is pi by 2. So we are making use of the first definition and solving it. So what we are doing is we are just considering the function. Here we are not using LHL, RHL. Only we are making use of the first definition. So see, at x is equal to pi by 2. So when it is equal to pi by 2, okay, the value of the function, the value of the function is equal to 3. So f of pi by 2 is equal to what? 3. Okay, next we will be calculating the limit of this function. So say limit of f of x as x tends to what? Pi by 2. Okay, as x tends to pi by 2. So see, when we substitute the value for the function, it is k cos x divided by pi minus 2x. Okay, pi minus 2x as x tends to pi by 2. Okay, and see, when I substitute this pi by 2 here, this is in 0 by 0 form. Okay, this function will be in 0 by 0 form. So we cannot substitute the value directly. So for this, we are making use of the substitution method, and we are substituting. Okay, substitute. Okay, substitute x is equal to, okay, x is equal to, we are substituting it as pi by 2 minus h. Okay, so we are making a substitution where there is x, we are replacing it by pi by 2 minus h. Okay, and when we make substitution for x, the limit will change. So as see, x is tending to pi by 2. Okay, as x is tending to pi by 2, in place of x, replace it by pi by 2. So here you replace it by pi by 2, and see what will be the value of h. So pi by 2 minus pi by 2, h value will be 0. So h will tend toward 0. Okay, so when we are making use of the substitution method, when you are replacing x with some other letter, the limit will also change. Okay, so x tends to pi by 2 will change to h tends to 0. Okay, so by making use of these two steps, the above function, see, the above a function can be written as limit. It can be written as a limit. See, k will remain as it is. In place of cos, in place of x, I will be replacing it as pi by 2 minus h. Okay, divided by, see, divided by, where there is pi, you keep it as it is. Pi, we will keep it as it is. Minus 2 into, again in place of x, we have to replace the same value, that is pi by 2 minus h. And here the limit is h tends to 0. Okay, so we need to simplify this further. Okay, see, on simplifying it further now, this will be equal to limit say k. See, cos of pi by 2 minus h, by making use of the formula we discussed, cos of 90 minus theta is sin h. Okay, so it will be sin h divided by, see, h tends to 0, you keep as it is. And see, in the denominator, when you multiply 2 inside the bracket, 2 into pi by 2, 2 and 2 will cancel, and 2 into minus h, it will be minus 2h. So in the denominator, we will get pi minus pi plus 2h. Okay, we get this term, and plus pi minus pi will cancel. So it will be nothing but a limit of h tends to 0, k into, say, sin h upon 2h. Okay, now if we want to make use of the formula, see, k by 2 is constant, we are writing it outside. Okay, and we will write it as limit of what, say, h tends to 0, sin h upon what, h. And sin h upon h, the value is equal to what, the limit of sin h upon h as h tends to 0, it is equal to 1. Okay, so this value we will be getting k by 2 into 1, which is equal to k by 2. Okay, so now we will make use of the definition. So see, by definition, what is the definition? A limit of f of x as x tends to pi by 2 is equal to f of pi by 2. Okay, so this is the definition. Okay, so see, here we have found out two values. One is given already. This is the equation 1, that is f of pi by 2. And after simplifying the limit, we have got the second value, that is k by 2. So according to the definition, 1 and 2 are what, equal. Limit of f of x as x tends to pi by 2 is equal to pi by 2. So we are substituting this. So k by 2, see, k by 2 will into 2, which will be equal to what, 6. Okay, so this is the next step. So k value will be equal to 6. Okay, so here you need to remember this method, very important, substitution method. Okay, so this substitution method, we are substituting x is equal to pi by 2 minus h. Okay, by making use of the substitution method, we need to simplify it, then make use of the formula. Okay, the formula what we are using here, a limit of what, sine theta. Two formulas from trigonometry we are using. This is one formula we are using, and then we are using the formula here. It is cos pi by 2 minus h. Okay, cos pi by 2 minus h. Okay, so these are the two formulas. This is the first formula, and this is the second formula. So on simplifying, we get k is equal to 6. Okay, so this completes the questions on continuity. So in the next class, we will be discussing important questions on differentiation. Okay, and differentiation, it will fetch you around about 15 marks. Okay, application and differentiation, it will fetch you around about 15 to 18 marks in your upcoming board exams. Okay, so this part is also important. So practice all these questions. Okay, and we will meet you. We will meet in the next class. Okay. Hope the last example is clear. All have understood it. Yes. Did you all understand? Okay. So with some more questions, we will meet in the next class. Okay. Till then, you all practice the examples on matrices, determinants, and continuity. Okay. Okay. Bye.